Okay, let's look at a SUVAT exam question. So, a particle is projected vertically upwards from a point O with speed u ms to the minus 1. The greatest height reached by the particle is 62.5 metres above O. Find A, the value of u, B, the total time for which the particle is 50 metres or more above O. So, yet again, let's make sure we underline the key points in the question. So, firstly, we know that the initial speed is u. So let's underline u. Next thing, the greatest height reached by the particle is 62.5 metres above O. So let's underline that. And that's all we're told. Now, let's draw a diagram with what we know. So, we've got our particle here, and we know that that's at point O. So there's the point O, and we're going to throw it vertically upwards. So it's going vertically upwards to a point, and then it's going to slow down, stop, and start falling back to the earth. Now, we're told in the question that the initial speed is u, meters per second to the minus 1. And we're also told the height above O to the top, where it stops and then starts to fall, is 62.5 metres. Now, once the particle has been projected, the only acceleration acting on that particle is going to be gravity trying to pull it downwards. So if we take positive as being this way, so if we say that's positive, then the acceleration that this particle is under is minus 9.8 to the minus ms to the minus 2. So, let's write in what we know in SUVAT and see if we can find out, firstly, what the value of u is. So, SUVAT. Now, what we're going to look at to answer this first part is we're only going to look at the initial bit between here and here. Because we know what the end speed is going to be when it hits the top. We know its final speed is going to be 0 before it starts to fall. We don't know its initial speed because that's what we're trying to find out. We know the distance it's travelled in that section. It's 62.5 metres. And we also know that the only acceleration acting on it is gravity, which is going to be minus 9.8 because we're taking positive as being upwards and gravity always acts downwards. Now, we don't know the time, so let's put a cross in time. So, we need to look at our SUVAT equations and think which one does not contain t. Now, if you just have a look yourself, you should spot that it's v squared equals u squared plus 2as. So, let's put in what we know. So, v is 0, so 0 squared. U squared, well, we can just put that. It's going to be minus, because we're looking at minus 9.8, so 2 times 9.8 times 62.5. Now, if you figure that out, you should get minus 1225, so 1225. Then, we can now rearrange this to get u squared on its own. So u squared is equal to 1225. So to find out what u is, we square root it. So u is equal to 35 meters per second to the minus 1. So we now know what the initial speed is. So, we've answered part A. Part B says find the total time for which the particle is 50 metres or more above O. So, let's draw another quick diagram with what we now know about this question. So, we know the particle is travelling initially with speed 35 metres per second to the minus 1. It travels vertically upwards and then it comes back down. And we said that that direction is going to be positive. Now, we're looking for all the time that this particle is 50 metres or more above where it initially started from at O. So 50 metres or more is going to be here, so that distance there is 50 metres. Yeah, again, we're going to use SUVAT to answer this question. And we're going to try and find out what the total time is from which the particle first passes the 50 metre mark to when it next comes below the 50 metre mark. So, let's write down what we know in SUVAT. So, the distance, the S, is going to be 50 because we're looking at above 50 metres. The initial speed we know is 35. We don't know the final velocity when it hits that 50 metres. We know the acceleration is minus 9.8 and the time is what we're trying to find out. So, if you look at your SUVAT equations, you should notice that the only SUVAT equation that doesn't involve V, the final velocity, is S equals ut plus a half at squared. So, let's substitute in the values we've got and let's try and find out what t is. So, S was 50 equals 35t minus half times 9.8 times t squared. So 50 equals 35t minus 4.9 t squared. Now what we want to do is we want to rearrange this equation so we're left with all the t squared t's and the number on one side and equal to 0. So then we can use the quadratic formula that you've learnt at GCSE and in Core 1 to find out what the two values of t are. So, if we do that, we end up with 4.9 t squared minus 35t plus 50 is equal to 0. So, remember, the quadratic formula is t equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So, the value of b is the minus 35, the value of a is 4.9, and the value of c is 50. So, t equals 35, it's minus the square root of 35 squared minus 4.9 times 4 times 50 all over 2 times 4.9. Now if you tidy that up, 35 squared is 1225 and 4 times 4.9 times 50 equals 980. So, next line is this, 35 plus or minus the square root of 1225 minus 980 all over 9.8. So we sort this out. The bit inside the square root becomes 245, so t equals 35 plus or minus square root of 245 all over 9.8. So now, remember that plus or minus means you can have the positive square root or the negative square root. So, the two equations we're going to look at to find t is t equals 35 plus 15.652 all over 9.8, and if you work that through you get t equals 5.1686, and the other one is t equals 35 minus 15.652 all over 9.8, and t is equal to 1.9742. Now, to find the total time that it spends above 50 metres, we need to do these two times taken away from each other. So, the final one is, so the time above 50 metres is 5.1686 minus 1.9742, and you get 3.19, which is approximately 3.2 seconds. And we completed that SUVAT question.